Okay, we are looking at the Unit 4, Lesson 1 homework. So, let's get started. The relationship between the amount of time a car is parked in hours and the cost of parking in dollars can be described with a function. So they're just telling us right away that it is a function. So identify the independent variable and dependent variable in this function. Well, I have two choices. I have time a car is parked in hours, and I also have, I'm going to do this in a different color, the cost of parking in dollars. So I have to decide which one of these is my independent and which one of these is my dependent. Well, independent I think of as the one that I get to choose, and I get to choose how long I park my car there. So I'm going to say this is the independent here, is time the car is parked. And that my dependent is going to be the cost of parking in dollars. So dependent. So I'm just going to write myself my answer as a sentence here, just so that I can be thorough instead of relying on someone to see my underlined things. So the independent variable is time that the car is parked, and the dependent variable is the cost of parking. Okay, so now part B is to describe that function with a sentence in the form of blank is a function of blank. So what I'm going to make sure that I write down here, just as a little note to myself, is that we do this a little bit backwards. We normally think of then input and then output, or independent and then dependent, but this is going to be that output is a function of input. And independent variable is our input. So if I was to write this sentence, I would say the cost of parking is a function of, and then my input, which is the time that the car is parked. So the cost of parking is a function of the time that the car is parked. Okay, so now we're going to look a little bit more at this in sort of a graph. So suppose it costs $3 an hour to park. So I'm going to make a little mental note of this, but also underline it for myself, $3 an hour, and a maximum cost of $12. We're going to sketch a possible function. So input is our independent, which is always going to go on our horizontal axis. So I am going to have hours on my horizontal axis down here, and I'm going to label these 1, 2, 3, just count by ones. So 4, 5, 6, 7, 8, and even 9. And then I want to make sure that I have enough to reach my maximum cost of $12. And I don't have 12 boxes here, but I do have 6. So I'm going to count by twos. 2, 4, 6, 8, 10, and 12. And this is going to be dollars on this side. So if it's $3 per hour, if I'm parked for 0 hours, it's going to cost me $0. So I'm going to put a point at 0, 0. If I park for 1 hour, it's going to cost me 3. So when I go over to 1 on the horizontal, I'm going to have to go up to 3 on the vertical. So 1 hour would be $3. 2 hours is going to be $6. 3 hours would be another $3 on top of that, so it's going to be 9. And then at 4 hours, we would add another $3, and that would make $12. Now, if this was just $3 an hour to park, that means at 5 we would add another $3. But they told us the maximum cost of 12. So at 5, it's still going to cost $12. And it's still going to cost $12 for every single hour beyond 4. So I'm going to connect all of these with a line because the price is going to be adjusted in between. So it's okay to connect all of these. I just like to use points to identify where I'm drawing my lines first before I put them in. Okay, so let's identify one point on the graph and explain its meaning, since that's part D. So I'm going to use my red pen here and I'm going to circle, let's circle 2, 6. So that's this point right here. So let's explain its meaning. Since I circled it in red, I'm going to put my explanation down here in red. So point I chose is 2, 6. Now, I chose that my horizontal axis was hours because that's my input. So that 2, that represents hours. And my 6 represents dollars. They just want me to write this in a sentence. So, parking for 2 hours costs $6. And I could have selected any point on my graph and I would have been able to write a sentence for that same thing. So if I had chosen 5 hours with a cost of 12, that would be this guy right here. I could change this so it said parking for 5 hours costs $12, and that would still be accurate. So there's a lot of different answers for part D. Mine is just an example. It is not the only correct solution. So let's look at question 2. This is a completely different thing. We're looking at burgers on a menu sign. So the prices of different burgers are shown on the sign based on the information from the menu. Is the price of a burger a function of the number of patties? So they're asking, is it? Which means we have to determine, is this a function? And what I know from functions is that one input should only have one output. So that's probably what they're going to ask us to check. Now, the sentence, a function of, also gives us what they want us to consider our input and output. So what they're asking is price of a burger, and this is output. And the number of patties, this is going to be input. Because we would always say the output is a function of the input. So what I'm looking at is does the number of patties affect the price? So let's actually look over at our menu here. I have 1 patty, $3.49. 2 patties, $4.09. 2 patties, $4.59. And 4 patties, $6.79. Well, just looking at this information here on the left, 1 patty, 2 patties, 2 patties, and 4 patties, I actually have one of my inputs shows up twice, which is my 2 patties. So this is what I have to actually look at in order to determine, is this a function? Because one input of 2 patties has to only give me one output. Are these burgers the same price? Just the patties? Or the patties and 2 slices of cheese? Well, they are not the same price. So it does look like cheese has an effect on our prices here, but for our purposes, we're going to say no, the input of two patties has two different outputs, which is $4.09 and $4.59. So it cannot be a function. That's our answer. It can't be a function because we have two different outputs for the input of two patties. And that input of two patties, if this was a true function, that would mean those burgers should have the same price. And they don't. So let's move on to question 3. That's on the back page, so I'm flipping my page here. Now they're giving us a situation, and we're going to select all true statements about the input variable of this function. So I like to look through what I have first. So distance a person walks, d, and kilometers, and they're saying it is a function of, and then time, t, in minutes since the walk begins. Now I know that this is a function of sentence is structured in a specific way. So the output is a function of the input. So that means that this is our output. And then this stuff over here underlined in red is the input. So if they're going to ask me information about my input, I'm going to reference that red portion right there. So select all true statements. Distance is the input. Well, I would disagree because I just identified time, t, in minutes. So we're going to say, nope, this one is not the input. Time is our input, but part B or question B here says time of day is the input, and that's not true because it's time, t, in minutes since the walk began. So choice C, this one seems accurate. Time since the person starts walking is the input. Yes, I would agree with this one. Time since they started walking is our input. Does T represent the input? Oh, yes, T in minutes since the walk begins. So D, I would agree with also. Choice E, D represents the input. D does not represent the input. That represents the output. Option F, the input is not measured in any particular unit. That is actually not true because they told us that time t is measured in minutes, so it is measured in a specific unit. It's measured in minutes. Oh, hey, question G or question option G or choice G says that it's measured in hours, and we just decided no, it was measured in minutes, so that's also not true. And then let's look at question option H. For each input, there are sometimes two outputs. So let's actually think about what this means. For each input, an input is time, right? Time. And our output is distances. At a specific time, maybe, I don't know, 6 minutes into my walk, could I be two entirely different distances? I cannot, unless you can bend time and space, in which case you could be in two places at the same time. This is not actually true because you can't be, according to this, in two places at the same time. So we will say, I'm going to write a little note here. can't be in two places at once. Okay, now let's look at question number 4. It costs $3 per hour to park in a parking lot with a maximum cost of $12. That sounds just like the question that we had on the previous page. But now we have this additional piece. Explain why the amount of time a car is parked is not a function of the parking cost. So it is not a function, and we need to explain why. Well, let's take a look at how they have structured this sentence. Normally, we would say output is a function of input. So what they're asking us is that time a car is parked, they're saying this is output in this situation. We have to explain why the time technically is not an output when our input is the parking cost. They're saying this should be our input. So I know that my definition of a function is that for each input, there should only be one output. So for each input, there can only be one output. So we can say time is not a function of cost because it is not a function of cost because, now let's actually review, and I'm going to go back to my graph. If I'm inputting cost, my output is time. So I want to know for each input, there should only be one output. Well, I have, if I switched these and had my input as 12, I would have multiple times that that's actually true. I'd have all these hours here, 4, 5, 6, 7, 8, 9, all of those times cost $12. So let's revise our answer or finish our answer here. It is not a function of cost because the input of $12 has multiple, or you can say more than one, outputs. 4, 5, 6, 7, etc. So it's not, time is not a function of cost because the input has multiple outputs at $12. And that's it for the main part of the homework. This question down here is a review/challenge problem. And since it is a challenge problem, I am going to leave that one to you in order to do your best with it. You can use some guess and check. But I would suggest, so I'll give you one hint here, I would suggest assigning a variable to each of these. So for the first number, I might talk about my first number as being x, and my second number, as y. And that should help you out with, I don't know, trying to figure something out with this one. But yeah, that is the end of our homework. We had 2 pages, or 1 page front and back. for Unit 4, Lesson 1.